We're broadcasting now. We're live.
Okay. All right.
All right. So see, we're gonna need the BLEU scores.
Yep.
Oh no, there's a dinosaur named George.
I can't continue under these
Oh,
circumstances.
don't eat daddy. Ah.
Go at me. Go at me.
Rescue bots, daddy's doing work.
What the hell? That?
You.
No, don't eat Georgie's neck. If I'd been thinking ahead, I would have pulled up these Excel files beforehand.
Yeah, I was just thinking the same. I'm in the same boat. I'm like, crap. I knew I was supposed to be doing something.
Oh, is the dragon eating a box?
No. Manu, eat.
Oh, the monster's eating a box.
Yeah.
I'm glad you guys don't have it pulled up already because I just barely flew into California. Now I'm catching on to the meeting. Glad we're behind a couple minutes.
Oh, anytime. We wanted, make sure that.
No.
Oh.
You're never at home, are you, Max? You're always flying around somewhere.
Going somewhere, doing
Getting
something.
miles.
Yeah.
No, I wish. We're just always personal stuff. I wish it was business, but we're just always on the move.
Yeah, my sister had a job that she was always traveling for, but they gave her the miles for it. They just reimbursed her for her travel expenses, and so she just got like an Alaskan miles card.
Yeah,
Mm-hmm.
that's what we should do with it.
I think I've got mine.
Oh, so for question 2, I've got the answer of a chi-square test of independence.
Okay, I haven't read it. I just got my Excels pulled up. Let me go and read this. George, can you go sit on the couch and watch Rescue Bots, please? Thank you, George.
Will it not just be a test of two proportions, Sarah?
So I would say no because because the word independence is involved.
Yeah. I agree. It's a chi squared.
Yeah.
Or chi squared.
There's only two. So the problem is there's only two things I agree.
Right.
But it's darn fact they're using that word independence, which makes me think that.
Where did they say independent?
So
Becky, this is a categorical test.
Mm-hmm.
And we're testing their independence. We're testing if the two things are independent of one another, which is a chi squared.
That makes sense.
although I really think it's chi because of the fact they're specifically using the words independent.
Yeah.
But I mean, there are two people, so I could see an argument for a test of two proportions. Let's actually jump back to the thing really quick.
To the reading?
And to the reading, because it is only two, so I mean, a chi is basically set up to handle more than two.
Yeah, it's a chart.
But
You need to determine if education level differs between the two countries.
it's at the bottom of the question, at the very bottom of the question, Becky,
Mm-hmm.
says, The question, what we're looking for is like, you want to determine if education managers that successful is independent of the country they are from.
But that's
Sounds,
not what, oh, I'm just reading, sorry. I'm reading the review. And the question on the actual quiz must be a little different.
yeah, no, you're okay. You're fine. That's why. Let's do this real quick. Okay. So score. Yeah, because so okay. Yeah, so it's a chi. Because the null is the null hypothesis they're independent. The alternative is they're not independent. So if you the word independent in a question, it's chi.
Yeah, independent. Yeah.
You're okay. I'm glad we double checked it.
Yeah, on the lesson review, the preparation work, it doesn't say the word independent, but on the quiz it does. So that's a good thing. Yeah.
It's okay. Don't worry. Just realize that they're jerks and I can mess with us. Question 3. I'll let you go for question 3.
Question 3, human resource manager. I got G for that, which is test of 2 proportions, but I'm not super confident about that.
I haven't read it. Hang on.
Yeah, it would be a test of 2 proportions. I agree.
Okay.
But I'll let Mac and Mark make up their own minds too.
I agree.
Yeah, looks good.
All right. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults. Of a total of 248 were classified as heavy players. Of these, 152 were male. To determine if the proportion of male heavy lottery players, the proportion of males in the population, which is 48.5%. Which hypothesis would this be the test of 1 proportion?
Yep. Well done.
All right, a student project compared the effectiveness of 2 different combination locks.
Right.
One lock turned clockwise first and the other counterclockwise. As 25 students participate in the study, each student was given a combination lock and asked to open the lock. The time it took them to open each lock was recorded. We wanted to determine if one of the locks would be open. Which hypothesis test would be most appropriate for this analysis? I would put it as test of 2 proportions. Is that right?
I'd go paired sample t-test actually.
But which lock is picked isn't going to be determined.
We're dealing with time. We're not dealing with.
Yeah.
Quantitative test, not a categorical.
Yep. Sorry.
No, agreed. But it's not. But in order for it to be paired, Mark, the lock you pick for A will have to determine exactly what lock it's picked for B, and that's not here. I really think it's a poorly worded question because it sounds like it's quantitative, but I actually think it's proportional. I think Mac is right with the test of 2 proportions.
Really? Because I was with Mark with the paired sample t-test because the students each get a lock.
Well, then also we're not testing proportions here. We're testing actual times.
So here you go.
Hang on a second. I need to keep Netflix going. Otherwise, I'm gonna have a riot.
Oh no, you're right. Never mind. They are right. I take it back. I just need to read it. It is paired sample t-test. It is because the student, it's not the locks, it's the students that they're timing. The students are the subjects.
Yeah.
Okay. So I think the locks were the subject. I'm like, that was sweet.
Are you good with that, Matt?
Sounds good to me. Sorry, I screw up every single one of these, so that sounds good to me.
No. Oh heavens, you're fine.
Yeah. Good.
I'd rather have us discuss it and make sure we really understand what's going on than have us blindly agree with each other.
Yeah.
No, it makes sense. Where we're going with time, I agree.
All right, who's up?
Your
You are.
turn.
Me? Okay. A bank employs two appraisers when approving borrowers for mortgages. It is imperative that the appraisers value the same types of properties consistently. To make sure the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be appropriate for this? I would say it's going to be two sample test. There you go. Independent samples T confidence interval, right? Yep.
Sure.
Independent.
So that would be delta.
Why independent rather than paired?
Because of the fact that so what they're looking at is the 6 properties that the people did on each side. The properties aren't going to tell you which property from the other person's appraisal is getting picked.
They're just independently surveying.
Yeah.
They're not the same properties. I was looking at that as the same properties for both of them, but they're different for each. Yeah.
Yep.
What did we decide on for number 5?
5 was paired sample t-test.
Okay.
Paired.
Okay, 7. Psychology majors. Okay. I got independent sample T confidence interval.
What do you put? Sorry.
Independent samples T confidence interval.
I'm thinking of the confidence of 2 proportions.
I was thinking the same thing with Sarah.
Yeah, it's categorical. It's whether or not they're happy with what's going on, which is a category.
And it's 2 proportions.
Yeah. Because they're looking at psychology. Becky, does that make sense?
Yes. Yeah. Yeah.
Okay.
All right. Double stuffed Oreos are supposed to be have twice the filling as regular Oreo cookies. I want to know if that's the true assertion by the company who make them. You want to do a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling of the amount of double stuffed Oreos in order to compare it to the filling amount of regular Oreos. This is a. Is this a paired sample or an independent sample? T confidence.
Independent. Although.
Okay, yeah, because it's like on first glance it would seem like it would be paired, but it's actually not because.
Where is it?
But it's not. There's not two. There's not 2. It's a 1 sample t-test.
Okay.
Because they're not actually measuring or comparing anything to normal Oreos. They're only doing this stuff.
Those tricky so-and-sos.
You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount found in regular Oreos.
Yes, but we're not. But we don't have anything to compare. They're not comparing it. That's what we're doing is we're getting the information so eventually we can compare it. But in this particular instance, they're not actually comparing it to anything.
Yeah, we're not also getting 55 regular stuffed Oreos and comparing.
Okay. So 1 sample T confidence?
Yeah, 1 sample T confidence. Yeah. These guys are jerks.
Between when would it be a Z confidence interval?
That's if you know that's if you know sigma, the standard deviation.
Okay.
Anyways, I might be muttering the word jerks under my breath as we deal with these guys. Okay.
All right, which one of the following best defines the notion of the significance level of a hypothesis? That is alpha, I believe, the probability of observing a sample statistic more extreme.
That's the p-test.
P-score.
It's a
P-value.
The
probability.
p-value, p-score,
Yeah.
whatever.
It's the probability of a type 1.
Yeah.
Sorry,
All right.
they're messing with you. They're just messing with you. Don't worry about it, Mac.
To be fair, the p-value and the level of significance are closely related.
Yeah.
They are closely related. And just remember the level of significance is the alpha, if that helps.
Right.
And half the time
Don't take it easy on me. You don't have to make me feel better. Just tell me you're wrong. Move on. We're good.
Here you go. Which one of the following best defines the notion of a p-value? That would
Dang
be
it.
Charlie. That's okay.
Yeah.
I initially was like, yeah, Mac. I'm like, wait, no, that's not right. Dirty rats. Okay.
This one I always struggle with, but I'm going with B. 95% of all 95% confident intervals actually contain the true mean.
Yes. So
Yes.
to reiterate what's his name told me, Brother Bennett told us when I went to the office hours,
Uh-huh.
anything in these that has the word can't involved is automatically wrong.
If it says can't, it's
Wait, what?
automatically wrong.
Yeah, chance is automatically wrong.
Oh, chance.
Okay.
Yeah, anything with the word chance in it, automatically wrong on these.
Okay.
And that's because it either is or it isn't. It's either 100% or 0%.
Exactly.
And it's not.
Okay.
95% of all 95% confident intervals actually contain the true mean. Okay.
So it either contains it, 95%, either do or don't.
Yeah.
Wait, so we agreed it's beta, correct?
Yeah.
Okay. Or Bravo, whichever word you want to use.
Or beautiful.
Or beautiful. We agree it's all beautiful? I think we should start making up our own alphabet.
That would drive
It's
me
every,
nuts.
All right, Marcos.
All right. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 3.3. What is the mean of the distribution of sample proportions? That's also 0.3, isn't it?
yes.
Yep.
Do we have to add another 0.300?
Won't hurt anyone's feelings.
Not gonna hurt. Yeah.
Oh no. Hang on.
Oh, hell. Hello, Dolly. Oh, hello, Dolly. That's what I just said.
Standard deviation is
Hang on a second. My iPad just wigged out on me. I might need to pump you guys for answers here.
Okay, we'll hang out. We'll chill.
Okay, what was number 2?
Oh, that sucks.
Yeah, sorry.
You're okay. Okay. At least we were like on 40. That would be even worse.
We should probably write them down anyways, just in case, right?
Okay.
Probably good
So,
call.
number 1 is true. Number
Yeah.
2 is the very last one, chi-squared. 3
Okay.
is test of proportions. 4 is test of one proportion. 5 is paired sample t-test. 6 is independent samples t-confidence interval. 7 is confidence interval for two proportions. 8 is beautiful, as Becky said.
Mm-hmm.
9 is also beautiful. 10 is cool kid. The kid is spelled with a C. 11 is banquet. 12 is
Okay.
0.30. Okay.
All right.
Okay.
All right.
Number 13, standard deviation. I got 0.046.
Me too.
I will do you guys. Oh,
I was scared.
You did good.
I
You're
got one
awesome.
right for the morning.
Hey. Portionless. Okay, hold on.
I think my iPad just
Oh.
froze on me again.
All right, so hold on, let me get there. So my computer randomly moved where my bar is at, like where my little bar thing's at.
Oh.
So I have to figure out where to put it. I might be swearing a little bit about this. Okay. We're doing a test of one proportion, correct?
Yes.
Okay, good. And Becky, because you're a rock star, do you just want to read what I need to have entered in because I haven't gotten that far?
Let's see. Let me find it again. I'm just going one proportion. So we need 50 as X.
Okay. And it's 100, correct?
Yeah. Oh, wait. That was a different problem. I don't actually have it input in anymore. Yeah, but
Oh,
I think
okay.
yeah. Wait.
Okay, let me double check this.
0.25 is the null. Confidence is
0.2.
0.25. And yeah, X should be 50, right?
Oh, 0.3.
Is it 30 or?
Yeah, it's a 0.3.
Oh yeah, you're right. 0.30, and
Or,
then N is 100.
Okay.
Is it 0.3 or 30 though?
0.3. Because it's a proportion. So remember, it'll never be more than 1. Okay, so what am I looking for again now that I've gotten this far?
You're looking for
Oh, the p-value. Got it.
and then you have to make it a less than, right?
Yep, less than. Da, da, da. Oh, yeah. I got a p-value of 0.000.
When I did, I'm trying to figure out what I did differently this time.
What do you have?
When I did the thing earlier, I got 0.876. So 0.25 is the null, which is C on the paper.
Yeah. So 0.25 less than 95.95 confidence, N's 100, and then X is 0.3.
Let me go over this again.
All right, come on. Where
George, get that out of your nose, you silly boy.
I am the crap that smells my computer. Okay.
George.
Oh,
0.8. Wow.
I think 30. Okay, if you put X as 30, then you get a p-value of 0.876, which is one of the answers on our preparation.
I think it's but you're supposed to be 0.30, not 30.
Well,
Right?
P equals X over N.
Oh, so So would it be 30 then?
I think it is 30.
That makes sense. So 0.876?
Yeah.
Okay.
Or in this case, do we use 0.25? I'm just looking at a previous example from the book.
No, 0.25 goes in to the null hypothesis.
0.25 is the null. But Becky's right because X would be 30 because the 0.30 is our p hat.
Yeah.
Hold up again, guys. Hang on.
Oh, Mark, you poor guy.
I think that's the right answer because in our practice problem, 0 is not an answer, right? 0.876 is an answer.
You know, Becky, you're right because the 0.30 is the p hat. So we would need to solve for X, which is X times n. I mean, which is the p hat times n to X.
Yeah.
So you're 100% right.
Woohoo. What do you think,
So,
Matt?
I got 0.841, which is close to what you got. Just I used the equation. So I found you find the z-score,
Uh-huh.
p hat minus p over the square root of p times 1 minus p over n.
Right.
And then plug that into the applet. And that's how I got 0.8 or whatever. 0.841.
I'm just going with, I got a number that was one of the multiple choice answers. And whenever that happens, I think I'm right.
Yeah, Becky, I just put all my stuff in and I've got the 0.876 as well.
Okay.
So Mac, if your x's should be 30, your n should be 100.
Yeah.
Your confidence interval should be 0.95. Your null should be 0.25, and your type of test should be less than.
Right. Yeah, so I got the p-value is 0.876 on this. So.
Yeah.
I must have. Okay. Yeah, I'm good with that.
Okay.
So which problem are we on now?
14.
14.
14. Okay. What was 13?
13 is 0.046.
Okay.
Okay. Now we're on 15.
What was 14?
0.876.
Okay. Up on the next one, I promise.
You're right.
Is it my turn?
Mac, do that last one.
No. I didn't do that last one, but whoever.
Becky did the last one, I think. Oh, no, I did the last one. Becky, it's your turn.
My turn. Okay. So on this one, we're going to be doing a paired sample t-test. We have a P1.
No, this isn't paired sample. It's going to be one of the proportions.
Yep. It's going to be a category 2 proportion, 2 sample z-test for proportions. So our x1 is 61. Yeah?
Wait, what? Oh, the 2, yes.
Z-test for proportions.
Yep,
So our
I,
X1 is 61, our N1 is 1563, our X2 is 15, our N2 is 579. Confidence level 95%. That gives us confidence interval of negative 0.003 and 0.029.
hold on. N2 is, what is 5. Alright, so do we have any idea what our type of test is yet?
Yeah, it's a two sample Z test for proportions.
Yeah, no, but are we greater than, less than, or equal to? Not equal to, do we know?
I don't think it has anything for that yet.
Not
Okay.
yet. It will eventually be not equal to, but we don't know that yet.
Okay, hold on.
So this is asking for the margin of error, which was not actually in the thing, but we do have our confidence interval, so we take 229 0.016 is my answer.
Hang on a second. Let me get my calculator open. Yeah, 0.016.
Okay.
Okay.
Bound is negative 0.003, if I remember right.
Hold on a second. 0.016. Oh, come on. 0.016. On those days. Okay. 16? Sorry. Negative 0.013, right?
Negative 0.003.
That's what I meant to say. I don't know what I just said.
Hold on, guys. Sorry, I'm falling behind you. So we have X1 is 61. I'm sorry. X1 is 61. N1 is 1563. X2 is 15, and N2 is 579. Is that right?
Yep.
Yep.
Okay. I'm there.
So then to get the margin of error, we just take 0.029 minus negative 0.003 and divide by 2.
Yeah.
Mhm.
All right.
Nice. Okay.
All right. 0.029. Sorry for 17.
There you go. For 18, it is alpha.
Let's see here.
Yeah.
19 is 1.458.
1.458. I've got 1.8. Just kidding. You're right. 1.458. You're perfectly right. I thought I was being funny for a second, but I realized I'm not going to act funny because one of you will punch me and I'll deserve it. All right.
All right. 0.145. Oh, geez, we're not quite halfway there. Are you going to be all right on time, Becky?
Yeah, I can push it to 2:15. We'll be okay. Sorry.
All right.
What?
I have to go get my son to an orthodontist appointment.
Wait, hold on. What did you say the p-value was, Mark?
I got 0.145.
Yeah.
For the
Did you
p-value?
change it to not equal on your thing?
Oh, I swear I put on equal. Okay, 0.145. You're right. Okay, hold on, guys. My kid just woke up from nap. 0.14.
I'm sorry for you.
No, it's okay. She's just. Yeah. Oh, she's awake. Okay, hold on. Give me a second. Give me a second.
So what was the level of significance?
It was 0.05.
Give me a second. I'm going to try and swallow her with more food.
So we're going to reject the null hypothesis, but on proportions, we have to do it on alternative, right?
That's a high test. That's why it's
Oh,
high.
that's just Chai.
Well, our p-value is greater than our level of significance, so we don't we fail to reject?
Yeah, we do.
Right.
Yeah, we felt
So- Doggy Delta.
Well, the very last one. F. Right.
Oh no, you're right. You're right. Yeah, no, there's not sufficient evidence.
No, I failed to reject the null hypothesis, right?
Hold on,
Right.
guys.
Yeah.
So that's Foxtrot.
Yes.
Funky fool.
Funky Covagina.
You guys gonna want to walk? Okay. Cool.
All right, I think this next one's a Chi.
I think so too. And it's the one I totally did not get. No, the next one, yeah. This one.
Put you in your. Okay. All right, guys, what number are you on?
We're on 22.
You're on 22. What number am I on? For 21, what did you guys have?
It's Foxtrot. We no fail to reject the null hypothesis.
Okay. Got it. So Flamingo. Got it.
Thank you, Sarah.
We're doing a chi. How to chi-square test.
At 6.579.
Okay. Hold on. That's got my
6.579 is that what you said?
Yeah, that's what I got.
Yeah, 6.580.
All right, so 22, you guys have 6.580.
I got 579,
That's
but
what I called as well.
Well, that rounds up to 5.
are we rounding to 3 or 2?
3.
So it should be 579? Yeah.
Sorry, what did you guys get? I'm here. I'm just not here yet. You guys have
6.5.
Right.
Is what we got, Sarah.
What did you get, Max?
6.579.
Okay. Okay, we're doing high test. Okay. Monkey snot. That is all I'm gonna say about that. Monkey snot. Hold on. For some reason, my computer just scrolled up to the very top.
Fun.
Wouldn't be a group meeting if we didn't have a bunch of computer issues.
True. Okay. All right. And that was 10. Okay. Categorical data analysis. Copy of category. Measuring chi squared. Monkey. Oh, good puke. Excellent. I love it. Good. Do you have a big bubble? That's what was bugging your tummy?
23. Who's got 23 here? And Sarah, keep working on it. I'm not rushing you. I'm just wondering who's taking this one.
Let's see. I did the last one. I did 22.
Okay.
Oh,
P-value, I got 0.087.
Oh
I
my.
think that's what I got. Hang on. Yeah, that's what I got.
Yep.
0.087,
Which
you
is
said?
higher than 0.05.
Correct. 0.087.
Okay. All right.
0.87.
0.0. Okay, 0.087, right?
Correct.
Okay, great. No, the p-value is greater than 0.05?
Yep.
Yep.
Okay. Fantastic.
And 25. Oh, they changed it.
And
We,
this is the one that we go off of alternative, right?
Yes,
okay, so,
that's the right guess. Do you believe?
so in the practice, they say, do you have sufficient evidence to conclude that age makes a difference in whether a person is a morning or night person? And I say, no, I fail to object. So no,
Yeah.
we do insufficient evidence to say that. So D?
I
I
got
think-
B. We have insufficient evidence to say that a morning person or an evening person is independent of age.
Yeah.
Delta?
It's beta.
Data.
Bravo.
Bravo.
We have sufficient
Beautiful.
evidence to say that being a morning or evening person is independent of age.
Yes.
Oh, sorry, I was scrolled down too far. I got Charlie.
Yeah, I
Charlie?
don't think
That's what I have as well as
Charlie, you're right.
kitty cat.
okay. I can go with C. I can buy
Yep.
that.
Good work,
Yeah,
everyone.
sorry, I scrolled down too far. This is upside down. That's silly.
Okay.
Okay. Recent book note that only 24 rates up to investors.
Okay.
Suck. Let's see here. So
I think it's a one proportion retest, right?
Yep.
where's your Momosaurus? All right. So
Step back in there. Okay, one proportion. X is 50 on the one sample t test. Null is 0.20. What was the N? Let me throw that my way real quick.
200.
200? Okay, thank you. Sorry, my child has decided that not only she woke up from a nap, but she needs to puke all over me, and she will not be happy unless she's sitting on my lap.
babies are
We're beginning-
fun.
We're getting to the point where we're starting to go into teething.
Ah,
A little bit more needy.
how old is she?
She is 6 months.
Oh goodness.
So for the lower, I might be skipping my thing, but I got 0.190 and 0.310 for 26 and 27 respectively.
Yep, that's why I've got 2. Hold on, let me get there. All right.
190 and what else?
0.310, 0.190 and 0.310.
All right, what's the equation for this?
We're just putting it into the one sample z-test for proportion.
Okay, but what's the equation?
There's no equation. You just put it in.
Oh,
Our x is 50 and our n is 200.
okay.
Yep. I'm sure there probably is an equation.
I don't know. Hypothesis is 0.2.
Yeah.
That's
Oh,
funny.
okay. Easy, Brett. Okay. Who's up?
Okay. Oh,
I don't know. I kind
Mark,
of skipped.
sure. Becky just manhandled 2 questions in a row.
All right.
I can do another one.
What sample size?
I don't understand the next section coming up.
My goodness, small monkey.
Okay, so let's see here. So we're looking at n equals 6 over, let's see here, 0.02
Oh my God.
times p star times 1 minus p star.
Guys, I'll be back. I'm gonna see if I can't get her now. I can't get her without me.
All right, sounds good.
Okay.
No, the prior estimate is 0.2.
Yeah, 0.2 times 1 minus 0.2, right?
0.8. All right, easy, Brett. Yeah, huh, George? Easy, Brett.
1537, is that what you guys got by chance?
That's what I got.
What'd you get?
7?
What did you get, Mark, there? Sorry.
What? I got 1.568.
I got 1537.
So we're looking for a sample size, Mark. So you don't want just one person.
No, well it'd be 2, but no, you don't.
Yeah.
So here, let's see what I screwed up.
You're fine.
Did you square the
Oh,
first
you know what? I see what I did. No, I put in 0.2 instead of 0.02.
Okay. And okay, baby crack is on for small child. Which
All right, so I got 15.68, which rounds to 16.
okay.
Let's look at 1537. So we got 1.960 divided by 0.02 squared times
Okay.
0.2.
Oh, that's okay. I missed the squared.
Yeah.
Yep, square it. Oh my.
So we're good with 1537 and we're all on board.
Yep.
Go.
And then 29. I'm kind of torn between Bravo and Charlie. Bravo would mean that they are not as good, which makes sense, but Charlie just shows that they're different.
Better would be bigger. Better is bigger.
Yeah, greater than.
Greater than. So beta.
No, that would be F. Your E.
Well, it's
Oh, you're right. I can't read. She's right. Echo. Elephant.
Enumeration. Oh,
Ooh, there's a good one.
Oh, cool. Don't draw on anything with that. Here's a piece of paper.
Is it
Oh, okay, yeah, draw in that book. That's good.
Who did that?
Do that.
Okay,
30 minutes.
the next one's alpha.
Yep.
And then I'm totally lost. I don't know what the value of my test statistic is or my p-value. As I go back to my, 1.768. Why do I not know that? I know it now. Okay, 1.768. Sorry, I don't know what's going on.
Where are we getting these numbers from?
Our lovely little sheet. The
What
one
do we put?
side's,
Okay.
yeah, it's still the same one we've been doing for like the last 5 minutes. We haven't done anything new yet. They just threw in a few random questions to throw us off.
I love you guys, but I despise this class.
This is just a class, I feel like.
All right, and we're doing greater than, correct?
Yes.
Okay, so the p-value is going to be 0.039.
Mhm.
Okay. So 33.05,
What was our level of significance?
correct?
Probably
Yeah.
that seems to be what they always put in.
It is.
All right, so we reject the null hypothesis.
Yep.
So A. Alabaster.
Yes. Okay, so alpha, correct?
Yep.
Fantastic.
Yeah.
Good child of mine. All right. Oh, heavens to Betsy.
For this next one, it is just a one sample t-test, I believe.
Let me crash my computer trying to open this thing.
Oh, good night. Wait, I don't know. I think this is a one proportion. These are proportions. Yeah, this is all proportions stuff.
Well, I know that we had this. Is it because I know we had something similar way back at the beginning?
Yeah.
No, I agree with. I agree that it's a t-score, isn't it?
As proportions, isn't it? Hold
Because
on,
we're
let
dealing
me.
with. Because we've got the data. It's the Excel that we downloaded. We've got the data to show the numbers of the scores.
It'd be really horrible if we had to do something else with these numbers before we put them into something. You're all done?
Yeah.
Oh, bring it over here. Let me see.
Yeah, no, it's these are proportions because it's the amount of how correct it is.
Oh, good job.
Done.
Okay, so what do we do with these numbers to get them into an Excel then?
It's categorical that it's the something. Oh, F. Maybe not. Maybe it is a t-test.
I think it's T because we're dealing with numbers results.
Yeah, I think
Well,
he's
just put it
right.
into the. I just put it into the t-test thing in my. Oh frick. All right, hang on. I mean, I have a t-score of negative 3,683.938.
I put it into the t-test and it came out good for me. Like I got a level of 0.282 to point. Yeah.
What's 0.282?
The null hypothesis mark, change that to 0.295.
Okay, hold on.
Is that what you did, Becky?
I have a null hypothesis of 10. Why do I have a null hypothesis of 10?
Give me a minute.
All right. Okay, that's
Oh,
better.
oh.
Yeah, that's better. I had a p-value of 1, which is
Ah.
I don't know, not good.
All right, so what's our null hypothesis?
It is
Anyone?
0.295. Yeah, you're right, Matt.
Is that right? I would not be too sure about myself today. I'm running on 0 sleep. So.
I
Yeah,
think
you are.
it is. Yeah.
0.295, yes. Yes.
Okay.
You are right. Well done.
And it's different, so it's just not equal to.
So
So
lower
lower bound is 0.282.
Yep.
295. Okay.
0.282. Yeah, that's what I got.
Cool.
0.293 for upper.
Wait, hold on. 0.282 for lower, right?
Yeah.
Okay, hold on. Let me make sure I somehow didn't. Okay. 0.282 upper. Sorry, what did you guys say upper was?
0.293.
0.293.
Let's see here. Degrees of freedom are 99. And negative 2.803 for the test statistic.
2.8.
And 0.006 for the p-value. Let's see, and then we have insufficient evidence to say that the true mean is different than 0.295.
Wait, what do you guys have for your p-value? Oh, 0.00.
I got hang on.
0.006. 0.006.
Okay, hold on. Flip back. Hold up. I'm a little behind, but let me get there.
Oh wait, is alpha 0.05 or 0.005?
0.05. Yeah, so we should.
Oh yeah. So I got that one wrong.
It's
It should be
Bravo.
alpha.
I got Bravo. Is that right?
Hey.
Yeah. So technically, Mac, if we were speaking regular people English, that would be right. But since we're in a statistics class, it's alpha.
Yep.
Because we're testing to see if the mean is different, and so we just don't change that language ever for some reason.
But isn't this based on, because we're using t-scores, we're not doing chi, isn't it based on null hypothesis?
Yeah. So let me double check this real quick. No, we have to, because we rejected the null. So we have sufficient evidence to say the true mean is different than 0.295. And the null hypothesis is 0.295. So we have sufficient evidence to say that it's different.
Okay.
Yeah. Alpha is. Oh, do I hate these guys more and more. More and more and more. Okay, so this is going to be a
It's going to be a dependent two-sample t-test.
Yep. No, it's going to be a paired
Yeah,
sample.
paired. Sorry.
Okay.
That's what I meant when I said dependent.
Okay, we followed.
All right, let's see, 0.05. Lower bound.
Where am I? What am I doing? That's what I'm doing.
All right, lower bound, I got 8.728.
Yep, that's what I got.
Hold on. I think I'm about there. Okay. 8.728, correct?
Yep.
Fantastic. All right, hold on.
Upper is 10.455.
8.728. What do you have for the next one, Becky?
10.455.
Okay, hold on. What's the next one?
And then the test statistic is.
I've got 22.446.
Yep.
I got.
Okay. Where are you at?
Degrees of freedom. 40.
Yep.
Oh my gosh. Hold on a second. I can't type anything right today. Okay. Degrees of freedom, you have 40.
Yes.
Okay.
P-value, I got
P-value,
Are we checking greater than, less than, or equal, or not equal to?
oh, I don't know.
Not equal to. Isn't it not equal to?
Should be greater than.
Greater than?
They're taller.
So 0.
Well, it's still 0.
1.3. So what's the p-value then?
0.000.
Yeah.
Okay.
And we would reject the null hypothesis.
Charlie. Okay.
All right. Wait, hang on a second. Let me double check this. Let me double check this. That. Make sure I'm not leading you guys astray.
Sorry, you guys. I was so off today. I appreciate your patience as I getting lots of my answers wrong.
All right. Yeah. So that's right. Okay. Submit quiz. All right. Try again.
93%.
Wait a minute.
Okay.
14.
Screw it. I'll take it.
25. And I think that's it. Yeah, but I've got to take off. So I'm
Okay.
taking.
Bye, Becky.
Hey, thanks, guys.
Story 6.
See ya. Good luck
See
on
ya.
the test. We don't have a
You
meeting
too.
on Wednesday, correct?
Correct. But just get if anyone has any ideas on what we want to do differently for our thing, let me know. I'll check into the
I like
dog thing. I can't get the high school on board. Other than that, let me know what you guys want to do.
I would like
I
to
like
go
the
with
dog thing. It seems like the path of least resistance.
Yeah.
Okay. But you guys keep thinking in
Yeah.
case the principal says I won't do it. See ya.
All right, I'm gonna go ahead and stop broadcast.